Hello and welcome to KX Insiders, the show that puts you, the developers, front and centre for all things KX. I'm Daniel Baker, Head of Evangelism, and in this episode we are going to discuss Wordle, the game currently taking social media by storm. For those who don't know, Wordle is a daily browser-based brain teaser that grants players 6 attempts to guess a mystery 5-letter word. After each guess, the colour of the tile changes, indicating how close the player was to solving the puzzle. A grey tile means the letter is not in the word. A yellow tile indicates that the letter is correct but not in the right location, and a green tile means that the letter is both included and correctly placed. Now I appreciate that many viewers may be watching this month's episode and wondering what Wordle has got to do with KX. And you're right, it does seem like a strange topic. However, there are lessons here in information theory and how we can use the power of code to address the daily challenges. To help me understand more, I'm delighted to be joined by Data Scientist Conor Moran, who's been building on the work of the KX community. Conor, welcome. So Conor, if I'm honest, I guess I'm more Street Fighter than Wordle. However, I can't deny its popularity and will often see my social media feeds full of posts from friends and family playing the game. Now, there are approximately 13,000 5-letter words in the English language, but as I understand it, Wordle narrows this down to the most common. But even that still leaves around 2,500, so I'm curious to see how it's solved in code. Could you explain?
Hey Dan, thanks for the warm welcome. So this is a fantastic puzzle that gives us a great opportunity to put on display the power of KDB+, whilst also learning a little bit more about how developers of different backgrounds might come up with unique techniques for solving the same problem. Before a single line of code is written, however, the developers must first build a framework for this problem so that they can better understand what exactly it is that they are dealing with and how they might go about solving the brain teaser. As you've touched on already, the software engineer who created this game gave us approximately 13,000 words to choose from, with his girlfriend deeming 2,300 of those words common enough to become a potential answer in any given game. This gives us an abundance of words to start with, but provides very little confidence in the efficacy of any of our initial guesses. Ultimately, we want to whittle away at this uncertainty and leave ourselves in a position where we can be confident in our answer in as few guesses as possible. Intuitively, the fewer the guesses, the more performative the algorithm will be. For those at the beginning of their coding careers, you can simply think of an algorithm as a well-defined set of rules that spells out a procedure to complete the task at hand. In this instance, we have a computer program, which contains an underlying set of instructions that, when given some input, will tell you how to make a decision, or simply make that decision for you. To give a more concrete example, there is one such algorithm that's especially adept in the world of Wordle, in that it revolves around the aforementioned idea of information theory through entropy. Without springing you into a full-blown lecture on the mathematical statistics behind it, information theory can be thought of as the quantification, storage, and communication of digital information. In this context, we can think of information as simply being processed, organized, and structured data that we've come to learn. When I use the word entropy, I just want you to think of the expected information value of a particular guess. When measuring information, we are measuring the number of bits, or the number of yes or no questions we would have to ask to reach the conclusion. Now, how do we tie these seemingly abstract concepts into our everyday lives during our lunchtime Wordle break? As positional clues are given to the player at every round, the set of feasible answers shrinks. The model, therefore, is to get the most amount of information out of each guess by eliminating as many incorrect options as possible, while simultaneously trying to reach the solution as quickly as it can. Again, it's all quite similar to how you and I might work out the answer, except the software can leverage a ranked list of thousands of 5-letter words from the English language, rather than whichever words happen to be rattling around our heads.
Thanks, Conor. Appreciate the explanation of algorithms and information theory through entropy. But the proof is in the pudding, and I'm sure that our viewers are keen to see how the code holds up with today's challenge. Could you therefore run us through a quick demo?
Sure thing. So as you mentioned, this all began in the KX community, via a post by Paul Carroll. From there, the idea grew in the minds of many engineers as to how best this might be achieved in KDB+. One particularly well-founded solution came from Nick Psaris, who noted that Wordle could be seen as an edge case for another well-known game, Mastermind. He therefore refactored all his old code, ensuring that it would better suit the end goal of this new puzzle. Let's jump into the code and perform a live walkthrough. From our queue session, we start with two command line options, namely lowercase s, to apply a specific number of secondary threads or processes available for parallel processing, and uppercase S, which we can use to set a random seed unique to our own session for generating final answers. Next, I will load the necessary library from the directory. This is a direct reference to the repurposed mastermind algorithms that we touched on earlier. From here, we can load the Wordle script. This contains everything we're going to need to set up and complete the task at hand. Then we simply import the data extracted directly from the Wordle website. As one can imagine, the best potential starting word out of all these 13,000 guesses will depend upon the algorithm of choice. Let's stick with our ever-topical maximum entropy algorithm for now. The last step of this initial phase is to now put all our work together and create a summary table, which will rank the words from most informative to least informative from a standpoint of expectation, i.e., how well suited are they to being the first word we use as our initial guess for this game. Once the ranking is complete, we assign the optimal word to a variable which we can now use as our initial guess. At this point, we have a choice to make. Would we like our algorithm to take the wheel here and complete the game entirely of its own accord? Or would we rather the algorithm caddy us with suggestions for what it believes to be the most astute next best guess? Let's run through both scenarios. Firstly, let's take the automated option and discuss what's going on under the hood of the code. As you can see, the challenge was solved in a few guesses, but looking at the resulting table, we can see how this was achieved. There are three columns. The first is n, and is used to display the number of possible choices left from our initial answer. The second is guess, or what the algorithm has chosen to input as its possible solution for this round in question. The last is score. This column holds all the information needed to select our next word of interest. This is a string, which can be thought of in this case as a list of 5 chars, each representing a letter space in our 5-letter word. An empty space is used to indicate grey. Y is used for yellow and G is for green. It's important to note that we see the value for n drop drastically with every guess. This shows us that the algorithm is removing potential answers that have now become redundant by considering the new information provided in the score.
That's impressive, Connor, but I think it would be a little more fun for us to get some hands-on experience. Can you show us the assisted method?
Sure. So to do this, we need to change the way in which the algorithm is interpreted. This will provide recommendations to the player, yet still allow them to submit their own guess each round. For example, our initial guess of soar hasn't produced any yellow or green tiles, but it has brought the list of possible answers down from 2,309 to just 182. The algorithm then provides a recommendation for the word Clint. However, in this instance, I will override and opt to input my own word, Flick, which returns one correct result and further narrows the possibilities of a correct answer down to 8. From here, the algorithm suggests the next word, width.
Hold on, if the algorithm knew that the third letter from Flick was in the correct location, why would it now suggest width?
The algorithm does indeed know that I is in the right place, but it now needs to remove redundant words and narrow down the solution even more. To do this, it wants to determine the letters W, D, T and H are present in the final answer. By suggesting the word width, the algorithm identifies that T is also correctly placed, effectively reducing the field of contenders from 8 down to 1, completing the puzzle with the word unity. So hopefully this demo has given you some insight into how the algorithm works and the power of KDB+. I also hope it highlights how one might sharpen their skill set in composing algorithms through Q code, because these skills can be used in more meaningful contexts in our professional lives.
Connor, thanks for the great demo. I'm super impressed with how the community have come together in solving these challenges, and would like to extend my thanks once again to Nick, who was kind enough to let us showcase his solution. If you would like to see more or try to code yourself, you can find all links in our community pages. What's more, we also have examples from other popular games, including family favourites such as Boggle, Klondike and Scrabble up on code.kx.com. Now before we wrap up, in the last recording I spoke about the upcoming community hack for our new KX Insights platform scheduled for March the 1st. We have seen tremendous momentum from our R&D teams and a wealth of new features being released. This includes updates to our stream processor and connectors that integrate across all major cloud platforms. We've also added our new PyKX Python interface that enabled KXSQL integration. With so many new updates, our trainers are taking the time to rewrite the hackathon content and ensure that learners get even more value from the event. To that, a revised date has been added to the registration page. We hope that you can still join us and look forward to showcasing the new functionality of the product. In the meantime, why not check out some of the other exciting news and updates on the KX community? Thank you.